Good day, folks. Let's look at this example now. This example is um, forces at equilibrium. Now let's read it. A box with a mass of 5 kg is held stationary. So this is the box is not moving. That means the F net is equal to 0. By two ropes is held by two ropes showed in the diagram below. Rope 2 is parallel to the ground, which is rope 2 and rope 1. So we'll say that is T1, T2. Let's label as T1 and this one is T2. Now what do you need to understand here? The forces that are acting here, it's this T2 in that direction and T3 in that direction. And also since this box has a mass, that means there's a weight, that means there's a force that the earth is exerting on that box that is downwards, right? So this is not moving, the F net is 0. Okay, now let's answer the question A. It says draw a free body diagram showing free body diagram for box including all angles. So the free body diagram, you basically show all the forces that are acting there. So we'll show there, we'll show the box by a dot. So we have T1 there, and then we'll have T2 there, right? And then we'll have the gravitational force downwards. We'll have the gravitational force downwards, right? And I think that's it. And then another thing that is important here is knowing that since there's that force that is 45 there, there's 45 there as well. It's an alternating angles, so it's 45, so the angle there it's 45. And if it's 45, the entire angle here it's 180, so this will be 135, right? And that's 90. Okay, but it's not necessary to show those angles there in the free body diagram. Now B, it says calculate the tension on rope 1 and 2. So we are not given, these two are not given the angles there. Okay, let's draw the vector diagram. What is going to help us is drawing the vector diagram. From the vector diagram we'll see what is happening there. Now drawing the vector diagram here, let's start with the gravitational force that is going downwards, which is Fg, and then secondly we will draw the T1. T1, it's there, and then the T1 is followed by T2 in that direction. Do you see? This is a closed vector diagram. This is T2, so that's 90, and this angle that is 45, this is 45. So if that is 45, that means this one is 45 as well. So that means this triangle is an isosceles triangle. Isosceles triangle. Why? That means this side and this side are equal. So therefore T2 and FG, they are equal, right? They are equal. The two sides in the isosceles are equal. So this simply means that the tension force, the gravitational force, we have to calculate the gravitational force, which is Fg is equal to mg, and then it's going to be, what is the mass of that is 5 kg, so it's going to be 5 times 9.8, which is 49 newtons. Therefore that means that T2 is equal to Fg, which is what? 49 newtons. So if we have this side and this side, we can find this side, which is the longer side, which is T2, T1. So we'll say T1 square is equal to fg square plus t2 square. We'll use the theorem of Pythagoras in order to calculate that. So we'll have t1 square root of fg square plus t2 square, right? So now the gravitational force, they're both 49, and the T2, they're 49. Remember, they are equal. So the answer, if you punch that in the calculator, it'll be 69.30 newtons. So this is what T1. Therefore, we conclude and say T1 is 69.3 newtons and T2 is equal to 49 newtons. We're done with that question. That's easy as that.